What if I told you there's an invisible force that connects a star exploding trillions of miles away to the simple act of you lifting your finger? Well, that force is energy, and it's not just some abstract term from science class. It's the power that drives literally everything. And today, we're going to figure out exactly how it works. So let's start with a little thought experiment. Picture a book just sitting there perfectly still on a shelf. It's not moving, not making a sound. It's kind of the definition of doing nothing, right? But does it have energy? Your gut reaction might be to say no way. But stick with me here. By the end of this, the answer might actually surprise you. The truth is, your life is just a constant flow of energy. I mean, the music you might be listening to right now, that's sound energy. The light you flicked on in your room, electrical energy. Even your brain, just processing these words, is powered by chemical energy. It's not something that just happens in a lab. It's happening all around you and inside you, every single second. Okay, so we know it's everywhere, but what is it, really? If you ask a scientist, you're not going to get some vague philosophical answer. In physics, energy has a very precise and very powerful definition. It's the ability to do work. So what does doing work even mean? It just means making something move or change. It's that simple. Think about a baseball player swinging a bat. The player's body transfers energy into the bat, and then, crack! The bat transfers that energy to the ball, sending it flying. Energy wasn't just created out of thin air, it was just passed along. And that idea of transfer, well, that's everything. Now here's where it gets really cool and elegant. All those different forms of energy we mentioned, light, sound, heat, you name it, they can all be boiled down to just two fundamental states. You can think of it as energy that's waiting to happen and energy that's happening right now. And we call them potential and kinetic. And this slide just nails the difference perfectly. Potential energy is stored energy. It's the energy of what if. What if that rock falls? Kinetic energy, on the other hand, is the energy of right now. It's anything that is currently moving. Stored versus moving. Once you really get that, you've basically unlocked the whole concept. So let's dive into kinetic energy first, mainly because it's the one we see and feel all around us, all the time. This is the energy of motion. The definition here is about as simple as it gets. If it's moving, it has kinetic energy. Period. It doesn't matter if it's a planet orbiting the sun or a tiny speck of dust floating in a sunbeam. Any movement at all, on any scale, is kinetic energy in action. Just look at these examples. You can almost feel the kinetic energy just radiating off them, right? The crazy spin of that saw blade, the frantic buzz of a bee's wings, the raw power of that motorcycle, the relentless push of a river. It's all matter in motion. It's all kinetic energy. Right, but let's be real. A buzzing bee and a speeding truck clearly don't have the same amount of oomph. They're both moving, so they both have kinetic energy, but what makes one have so much more than the other? It all comes down to two key ingredients: mass and speed. Basically, how much stuff is moving and how fast is it moving? The heavier something is, and the faster it goes, the more kinetic energy it's packing. It's that combination that determines its power. This little experiment shows it perfectly. Let's say you roll a super light ping pong ball down a ramp. It just kind of nudges the cup at the bottom. But then you roll a much heavier golf ball at the exact same speed, and bam, it sends that cup flying. That's the power of mass. Same speed, but more mass means way more kinetic energy to transfer. Okay, so that's the energy of things that are moving. But what about the energy of things that are about to move? Well, that brings us to the other side of the coin. Potential energy. Potential energy is, quite simply, stored energy. It's a coiled spring, a drawn bowstring, a rock just sitting on the edge of a cliff. It's energy that's just waiting for a trigger to be released, and it's all about an object's position or its shape. And this breaks down into two main flavors. First, there's gravitational potential energy, which is all about height. The higher you lift something against gravity's pull, the more stored energy it has. And then you've got elastic potential energy, which is what happens when you stretch or squash something, like a rubber band or a spring. You can almost feel the tension in these images, can't you? That climber, way up high, is just a storehouse of gravitational potential energy. Same for that diver, poised and ready to go. And that stretched rubber band? It's practically humming with stored elastic energy, just desperate to snap back. It's all potential, just waiting for the right moment. So how do you get more of it? Well, for gravitational energy, you either increase an object's mass or you increase its height. The heavier person on the higher diving board has more potential energy.
For elastic energy, you just increase the stretch or the squeeze. The further you pull back a bowstring, the more potential energy you're loading into it. Okay, so we've got the energy of motion and the energy of position. But now we've reached the most profound, the most important rule that governs them both. It's energy's golden rule, and it changes everything.
And here it is, the fundamental truth of the universe. Energy cannot be created or destroyed. It can only be transferred or transformed. So when that ball rolls down the ramp, its potential energy doesn't just disappear. It converts, moment by moment, into the kinetic energy of motion. And this has a name, the law of conservation of energy. It means that the total amount of energy in the entire universe, from the very beginning of time to the very end, is fixed. It never, ever changes. It just shifts from one form to another.
And there's no better example of this than a roller coaster. Imagine you're in that first car. Click, 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 climbing slowly to the top. You're barely moving, but you are being loaded with an incredible amount of potential energy. Then you tip over the edge. All of that stored potential energy instantly starts converting into pure kinetic speed as you plummet. You hit the bottom at maximum velocity, and all that kinetic energy is what throws you up the next hill, converting right back into potential energy for the next drop. It's this perfect, thrilling dance between potential and kinetic.
And that brings us full circle. Now that we understand potential energy and kinetic energy and the big law that connects them, let's go back to that quiet, still book on the shelf.
Remember this one? A book, sitting completely still. After everything we've just covered, what's the verdict? Does it have energy?
The answer is a resounding yes. Because of its height, gravity is pulling on it, which gives it stored gravitational potential energy. It has the potential to cause change. The moment it gets nudged off that shelf, all that stored potential energy will transform into the kinetic energy of motion. So next time you look at a seemingly still world, remember, everything is just bursting with potential, waiting for its moment to move.